All right, let's see how this goes. How's everybody doing? Welcome to the stream. Whew, all right. And if you're still here, Clem, great to see you. Okay. Oh, you know what? That is not... Oh, these are backward. That's what's going on. That's what it's supposed to be. So I found this new software, and I think somebody told me about this a long time ago, and I never looked into it. But it's an open source project that drives the Stream Deck, and I love it. Well, let me back up. I really like it. I started loving it because this afternoon I figured out how to do some things that I couldn't figure out the other day. Like, it just dawned on me where to go click, and yeah, it's like I'm starting to get it, if you will. I'm fixing. Oh, this is a logo. This is supposed to be this one, but it just does a handful of things better than the stock software does. Okay, so if I do this, so this one and then back to this one, but I lost the the one thing I liked about it. It just stopped doing. So never mind. Whatever. Okay. Here we go. Let's get some schematic stuff going. Yeah, so we are still working on this Apple II schematic. Remember, this is one that somebody had provided to BitPreserve. It had a number of issues, and so we've been recreating it. Well, we've been fixing it, which is effectively recreating the schematic. And so, yeah, we're just going to keep headed down this path. I think we're getting close to being able to run ERC and like be able to do something about the messages it gives. So let's find out, or let's see where we get today. All right, so let me think. I want to do something like D or G. We're going to use G and bring this down. I want to move all these blocks down. I think I can do something like this, because let's see, let's highlight everything in here. If I G this, OG, what's going on here? Okay, that looks better. I wanted to move that stuff down just a little more. No, why did I mess that up? Come on, really? Like, for real? That's silly. Okay, because what I noticed is this block up here is looking super, super crowded. And so I want to do something about that. Is it getting keyed out? Yeah, so cool. I love when that happens. Although I think the light is shining on it so bright that it like, yeah, it's like hiding the green. I'll have to figure something out there. So this is a story that only I will ever. I in the lab. I replaced all of my LED bulbs with much higher, with 6,000 6,000 Kelvin lights, and they are LEDs that are 100 watt equivalent, which is absolutely fantastic. The ambient light in there is now where I need it for shooting video, especially quick video. The problem is the bulbs, after I installed 12 of them, and it wasn't until I started editing a video I realized the bulbs are flickering. And if you can actually see the rolling pattern in some shots. I'm like, I was so mad because I noticed it when I did the green screen for the Mega 2 video, but I thought it was my ring light that was flickering, because I rarely use it. So I was like, okay, well, maybe it's just the ring light. Kind of makes sense for still photography. It's probably never going to cause a problem. But no, it's the ambient lights that I installed. So I put in all those lights and or all those bulbs, and I've pretty much got to rip them all out now. So I am not excited about that. And I've got to find another light that works. Because now I want the lights to be that bright. And I need them to be that white because I hate yellow showing up in video. I don't think there's anything that makes a video look worse than something that's graded in the 3,000 to 5,000 range. It just doesn't work for me. All right, this is a pain in the butt. However, I don't really have a choice. Oh, I was doing screen captures, wasn't I? Yeah, okay. So H1, and then let's do H0, and then H2, and then 3. Okay, this is not too painful. I can handle this. This is nice. So in other news or updates, earlier this week, I spent about an hour playing around with KiCad 799 or KiCad 8 Nightly, and that's coming along really nice. I think I saw the anticipated release date is January 24th. And so what I'm thinking, depending on how tonight goes, next week we may actually spend a little bit of time in KiCad 8 just to see what new things we can find. I've sort of gotten, I don't want to make it sound like I had this as any kind of plan, but with 6 and 7, I did streams on both of those right before their release just to get an idea of what's coming out. And so I think the timing kind of works out. Even if we don't finish this schematic tonight, I think that's what we'll do anyway, just because I think next week I don't want to do anything too crazy. That's phase 0. So when I'm clicking on the when I click on the thingies, the wires, if you look I can't. Okay, I'll use my mouse. So over here in the far left hand corner, it actually tells you what the name of the net is. So I'm looking at each of these trying to figure out where they're supposed to go. There, duh. Okay, so it's phase 0, phase 1, and Q3. All right. And remember, Q3 in the Apple II is actually a 2 megahertz clock. So phase 0 is 1.012 megahertz, I think. I really hope that's what the frequency is because I keep telling people that. And then Q3 is twice that, which is effectively the clock that the RAM is clocked at. And then phase 1, I forgot to say, phase 0 is the 1 megahertz clock that basically runs 6502. And then phase 1 is an inverse of phase 0, which I'm not 100% sure of all the places it gets used. The difference between phase 0 and phase 1 is something I haven't gotten very familiar with because in the Mega 2, that's all internal to the chip. The only thing that comes out of Mega 2 is phase 0. I don't think phase 1 comes out. So I've got a bunch of Element 14 videos that I am finishing, in the process of finishing. I hate that phrase, in the process of. I apologize. I won't use that again. That are in process. Once those are done, the first Apple II video I'm going to do is on the clocks. The biggest thing I want to show off is how. So what I plan to do is go back to the Mega 2, probably the Rev 2 design, and start talking about each of the boards and the blocks of the design, because I realized I don't really have a really good documentation on everything I did. All I've got are the couple of videos, which are just super high level, and a couple 100 hours of live stream, right? It's too much stuff to go through and try to figure out. And it's there's a lot of things that I don't want to forget. And I also think it'll just be kind of interesting to use the Rev 2 stuff as kind of a teaching bed for the Apple II. Yeah. don't know how far I want to. I don't know how much I want to commit myself to, but I've actually thought about, literally have thought about sketch. I started sketching it, and then my drink came, so I stopped. I started sketching an idea of building a Rev 2 style system for the Apple IIe. So basically, rebuild the Apple IIe, but just with Apple IIe hardware. So basically, or another way to think of it is, it would be like making a hardware development platform of the existing IIe. One kind of driving reason I was thinking that might be interesting is because I think that would actually be useful to other people. Like, Rev 2 is only really useful to me because I needed it for Mega 2. But if you're not building a Mega 2e, it's not too helpful. But what if I made a system like that was focused around the 2e? I think that might be a little more interesting to a larger number of people, and it'd make really good educational platform. In this context, educational platform about the Apple II. I don't actually mean like engineering education. So, I don't know. That's on my list of project ideas. Yeah, okay. So all of these clocks are basically connected to each other. That's interesting. Where's Raz? Raz is over here. Where's Kaz? So Raz is up here. I'm gonna click on Raz, and then I'm gonna hit the tilde. Wait, this is not PCB. We're going to click on Raz. Oh, it doesn't. The schematic doesn't know they're connected yet. That's why. But it looks like the only place I see Raz is here, clock, video, and RAM, which, given what it does, makes sense. So I wonder if we could get away with doing something like this. I think we can. You know why? Because I'm going to do it anyway. Oh, that's not going to work. Something's wrong there, but that's okay. We'll come back and figure that out in a minute. There we go. Ooh, look at that. It's all lit up now. It's like a Christmas tree. All right. So then what I was thinking is, what if we then, is that? Okay, so that's where, there's a Raz here. Ah, gosh, okay. Which makes sense. And then Kaz probably only goes to the RAM. Oh, it goes to the RAM multiplexer, which then creates the CD and E Kaz. Makes sense. Okay. So I really need to move this somehow onto here. All right, so I think what I'm going to do is I'm going to delete these lines because they're in my way. I'm just going to make this block slightly larger. Nope, that's not what I wanted. And then I'm going to grab these, bring these up. Okay, now. Okay. Well, this is not how I was going to do it, but I just noticed this. AX. I wonder what AX is. I almost said that's probably auxiliary, but that doesn't make sense. Not in the 2+. Come on. So if I delete these this time, all right. Oh, come on. That's not right. I don't really know what it was trying to do there. I guess what I'm I didn't even think about what I'm doing is this whole thing's going to come down. Is that the right? Nope. Come up one more. How's this look? That looks like a mess. Let's just delete all this and start over. Nope. Do the right drag so we only get the, but then you want to take those away from me. No, no. Yeah, telling me it's time to stand up doesn't do me any good right now. Thanks, watch. Wait, why is it telling me to stand up at 620? Oh, it's telling me I haven't worked out enough yet. Thanks. That's just what you want to hear when you're... I'm worn out. I'm not going to do anything else the rest of the night. You should work out. Yeah, thanks. That's not helpful. All right, let's get these lines over. What's this one? This is VA. Use G to bring this up. What's this one? VB. All right, and then I lost VC, which is not venture capital. Man, I think I've told this story before, but I'm going to tell it again. So when I lived in Menlo Park, that's right next to Palo Alto in California. It's also where the headquarters for Facebook is. And there is a relatively famous venture capital firm, Sequoia, over on Sand Hill Road, which was just a couple of miles from my house. And I'm trying to think, I used to drive somewhere that I would always like drive by it. I can't think of where I would go. Anyway, that's not part of the story. So the Starbucks that was by my house, which was only like 2 blocks away. Well, there was like 3 Starbucks that were only 2 blocks from my house, but that's beside the point. This particular one was in a, what we would, most places you might say strip mall, but like it's the fanciest strip mall you'll ever see, because the anchor was a venture capital firm. And so I think it was Thursdays. It was either Tuesdays or Thursdays. I don't remember which day, but they had like, I guess what would be called pitch day. And so I liked going to the Starbucks, and I would work from there and listen to people practice their pitches because it was in the same parking lot. So it was the Starbucks and the venture capital firm. And so people would be in there practicing their pitches. And one of my favorites was somebody always would say, we just want 1% of the market that Facebook has. And it's like, anytime someone is trying to pitch you an investment and they say, we just need 1% of a super big market, you immediately just forget it. That it's ridiculous. That is a ridiculous compare. Why is this Raz? Oh, I see what happened. That is not Raz. Because if there is a super big market, getting 1% is going to be ridiculously expensive. Hey, Tamaz. How's my week been going? It's been going great, I guess. I don't know. Same stuff, different day. There we go. All that because I want to connect those two. I thought there was one more over here. Wasn't there a Raz? Oh, Raz is okay. So what if I move this one over? Okay, that's what I was doing. So I had that. But what if I did this? What if I said, okay, come down here and we'll connect it to there. So then we can delete this, this, and this. Man, this is why I like just to use labels. But as I've explained before, on these multi-sheet schematics, I really like doing actual wires because it allows you to see how things are getting overlapped. Like, for example, I'm looking at this now and I realize it may actually make more sense to take all of these signals and wrap them up around this way and come back around, just to kind of show how they're connected. But I'm not. I think my focus is going to be get things connected, get back to the point where E or C passes, and then we can think about how to optimize stuff. Because this rework has taken way longer than I thought it was going to. I did not expect this to be like a 8-week project. I mean, at this rate, I'm not going to finish updating the bit preserve schematics to KiCad 7 before KiCad 8 comes out. So, yeah. All right, soft 5. Let's move this one to here. Let's move this one up here. All right. Let's see, phase 1. Okay, for the moment, I'm just going to leave it right there because I don't know where else to put it. Yep, there we go. DMA probably goes to the connectors because I think that is a slot signal. IRQ probably goes to the connectors, but IRQ doesn't go to the CPU. What? No way. No way. Does the 2+ not use the IRQ line? Huh. I'm going to look up something really quick because that doesn't make sense to me. All right. I bet that won't update now, but we're going to try. Which book do I want to go look up? Let me go into my... Okay. I am trying to remember. So a couple of weeks ago, we realized we almost realized the schematic that this person was using. I was going to look at this one to see. Has this got the CPU? No. That's not it. There it is. Yeah, so IRQ goes to the slots. So that should be leaving the... That's weird. All of these. I thought these were slot signals. So... why don't they have IRQ leaving here? Huh. Well, here's something else we're going to fix. We're going to change all of these to 1mm. This whole section is really messy and it's driving me crazy. All right, so then what? Did I do move? Yeah, that's what I did. Okay. So I'm pretty sure NMI, ready, and IRQ are all supposed to go to the slot. And yeah, okay. I don't know why they didn't escape them from this page. Well, it doesn't matter. We're going to do it right now. So I'm just going to do it this way. Let's change this to IRQ. Change this to IRQ. Okay, IRQ. And then let's see, what else do we need? We need NMI. Yeah, these are all inputs. NMI and then ready. So NMI is non-maskable interrupt. IRQ is interrupt. Ready, or RDY, that is that's actually how a card can that's how a card can pause the processor. DM or no, I don't remember, because DMA, the signal DMA, is actually how you pause the clock, and in the 2 plus and original 2E, you can only pause it for like 6 or 7 clocks, because pausing the 6502 prevents RAM from getting refreshed. Or wait, no, that's not the problem. The problem is its internal registers are dynamic. The 6502's internal registers are dynamic. And so they can't, oh wait, I already have DMA. What am I doing? Ready. Yeah. Okay, so now we'll leave this page and I will right click up here. Wow, what happened? Why did it jump like that? Let's do import sheet pin. I'm going to put them over here for the moment just to get them imported, because what I want to do is move all of these up. I'm going to move all of these down. And then we're going to put them in the same order, you know what I would like to do? I know what I'm going to do. I'm going to come in here. I'm going to hit, I don't know why I just hit. I'm going to do this because what I want is to copy that order. I'm just going to put that over here, cover up my face. Okay, so then we're going to have reset NMI, IRQ, DMA. Well, I'm just going to put it on the bottom then. No, stop. That's not what I wanted. Are you kidding me? Come on. Come on. All right, IRQ can come up to here. Ready, and DMA. Okay, got it. So then over on the slots, we'll do the same order. We shall do reset, NMI, RQ, which is now here, ready, and DMA. What about inhibit? Think. Inhibit is for the ROM. So there it is. Found it. All right. So then we're going to move this over here. Okay, so that is actually, we're going to put that on the top, and you'll see why in just a second. So let's move DMA to here. Let's bring ready to about here. IRQ to here. NMI to here. Reset. Inhibit. All right. So DMA will route, well, route's not the right word. Wire first. All right, and then we'll do ready, or ready, or RDY. All right. IRQ. I remember IRQs from the early days of PCs and DOS when you only had like a couple of IRQs available and different cards. You had to configure for which IRQ they were going to use. And then when Windows 95 came out, they had the plug-and-play spec, which, 30-something years later still doesn't work. I guess that's not true, only because we got rid of PCI. So, PCI Express doesn't really count because it's not really a shared bus. All right, let's bring our NMI up here, or not NMI, let's bring inhibit. I hope this is inhibit. I'm going to stop short to make sure this is inhibit. Yep. All right, that looks good. All right, what is that mess? Come on. Hey, I'm a professional. That's not fair. You can't have it that way. That's right, because I'm a super serious streamer. Okay. So I think that's starting, man, that really starts to cover a lot of the critical signals. IO strobe, I feel like should come from the RAM or the decoder. Wasn't there a decoder block? Huh. I don't know about that. And I don't know what user 1 is. I don't recognize that one. But we will do something like this. And then the C000, I don't know where that would, that's all the way back up in the ROM. Oh. That's not cool. There's IO strobe. Why would the ROM have IO strobe? I have to think about that for a minute. Except, I know why. Duh. Because that's for the expansion ROM. That's why. I think. I don't know. That's my guess. Okay, so let's do this. Let's bring this over here. Let's bring this over here. Let's bring all of these up here. So I need to get those two signals to the slots, correct? Well, IO strobe has to go to the slot. And the C00 to C7FF. Yeah, that's the expansion slot ROM, right? Or is that that's soft switches, isn't it? But no, never mind. That's the expansion ROM, I think. Yes. Hey, Christian. It's going well. How are you doing? More pain and suffering. Oh, you know what I forgot to do? Hey, this is easy. We can do this real quick. Oh, yeah. That's easy stuff. I like that. All right. So let's see. How do I want to handle this? What was this signal up here? Phase 1. Okay, let's reconnect that. I'm actually tempted to do this. Let's bring this guy over here. And then these two to here, because what I want to do is something like this. And then I think this is actually going to move up. And then I can move this down. Oh, nope, not move. Use G. If I use the G hotkey, that's drag. Then I'll take the wire along with it. Hey, Francois. Does PCBWay do email verification? Is that how they keep you from like signing up for multiple email accounts for the coupons? Oh wow! Look what I did. That was really dumb. That is not where that's supposed to go. That was. Yeah, that's not what I wanted to do. All right, let's bring this down to here and do one of these. Hey, I'll bet you. I'm not. How's your plugin work going, by the way? I vaguely remember seeing you say something like maybe you got it working or you're close to getting it to do what you want. I don't remember. I've been working on this video that I'm going to finish after the stream for 6 weeks now. I changed it 3 times, and each time the reason I changed it was because I thought, well, this is going to be easier to make. And yeah, that was a lie. So anyway, I've only been paying partial attention in Discord basically for like the last 2 weeks in Discord. The only time I paid attention was when I was waiting for something to render. All right, so if I reconnect these, actually I'm going to wait on that because what I want to do is I want to take this guy. I want to move all of these over. I'm going to draw a wire up to here so I can grab these and, whoop, hey, what are you doing there? Move those over, and now we'll connect the lines. I can move this over to here. And then that is going to connect somehow to this mess. And then gosh, I don't know what I'm going to do. If I bring this over here and then bring this, is that going to work? Nope. But I can come around this way. This turned into a major mess. Is it me, or is that not actually very clear of what we're looking at? That looks very good. Oh, that's cool. You already got your stuff merged. That's nice. Oh, okay. Maybe that's what I was, because I did see you say something about KitKat or KiCad. Excuse me. That is a plugin that I have not played with at all. I had a board. What was it? I had a board in mind that I was like, this would be a good one to panelize. And I don't remember which one it was. All right, so where is the 7 meg clock? That is the only place it's at. Well, that's stupid. Well, then I'm going to do this. I hate that, but what else can we do? All right. Yeah, is it? It's not really keying out though, right? Because the light is. So this is really dumb. Years ago, when I was first starting out live streaming, and funny story, I was drawing the Apple IIgs schematic in KiCad, and early on, I held up the PCB to show people, and it got keyed out. And then you know what I did? I was like, oh, here's the board. And then it keyed out. And I was like, oh, crap. So then I said, let me try and help. And I put my hand behind it. Like that was going to do something. That was good old days. Okay, I want to change this. Because what I want to move is I want to move this down here, and then why is that connected to read write? Well, that's interesting. Because what I want to do then is I'm going to bring this like out here somewhere. So Y is read write is, you know what it is? I'm dumb. I think I actually made it that color. Yep. That's a bad color to pick. Let's go with like a darker magenta. There. The only thing I've heard of with any of the Asia-based houses rejecting panelized stuff from KiCad or KiCad or whatever, KK, is just that they'll sometimes want to chart. Well, no, if you panelize it and when you place the order you tell them it's panelized, they probably won't care. The only thing I can think they would get upset about is if you're trying to make a panel of multiple designs, because they like to charge you per design. So that's the only thing I can think of is like the outside of it violates some design rule. I could see them saying, nope, we want you to pay extra for each design. Especially if you're doing their low cost service, which I don't think is like, I don't know. That doesn't. Well, I have mixed feelings about that. I was about to like defend them, but number one, I don't want to defend any of those places because they all annoy me. It just so happens that PCBWay tends to annoy me the least. So I actually do think I'm going to be a jerk so my plan right now, what I'm hoping to be able to do is by the first week of the new year is start releasing Add-Ohms videos again. And I want to make a fake commercial where I proudly say this video is not sponsored by any PCB manufacturer. Just because I'm tired of seeing people like, never mind. I'm going to stop. Doesn't matter. It doesn't matter because what'll end up happening is I'll get a deal that I actually like, and then I'll be like, I will have eaten my words, so I'll just stop talking. Okay, I know what I want to do. I'm going to take all of the, oh my gosh. I want to make this block smaller because it's messing me up. So we're going to move all this stuff down to about, well, I'd want it to move it to here. And then let's move this down to, say here. And this will move to here. And then let's grab this one and move it down to here. Because I want to make this block larger for these additional signals. So like this one. Yeah, same thing on this one. Let's move all of this stuff down because there's no reason for it to be up here. Let's try this. This video is sponsored by Anyway. Oh, I love that. I'm going to steal that. Yeah, well, I mean, that's sort of why they don't want you to panelize your own design, because then you end up taking up more space on the board. And so while maybe yours, I don't know, I'm just thinking off the top of my head. So the surface area you end up using, yeah, you pay for that, but because generally if you take up more space, like a larger design, you may actually end up paying a less price because they can charge like $5 for each design inside of it. And so it's actually more beneficial to them to sell smaller spaces, right? I think that's what's going on. I don't know. I'm mixed about it. For the reason I'm mixed about it is because I think I'm not going to get into it. I don't want to get into it. It is what it is. So. I mean, I don't know. The only comment that I want to make is it just feels to me like their volumes are so high. Does it really matter? Like, really? You know, even if somebody's buying a panel of 100, well, I guess that's one thing they're trying to prevent. Okay. So one reason I can see them wanting to charge you per design is it would prevent me from creating a storefront and selling their service with, to other people. And I'm not picking on them. This is, it's the Osh Park model where, Osh Park is not a fab. They have a deal with a fab and they're just the middleman between you and the fab. And so I think maybe that's one reason that the Asia houses don't allow you to, or they want to charge you per design, is to prevent somebody from doing something like that. I don't know. Whether that's the reason or not, I don't know. But I could see that being one of the reasons, if that makes sense. Because in the back of my mind, I'm thinking, well, if I give you a panel of like, let's say I have 3 things I want to get made, and I just decide, okay, I'll just panelize all 3 of them, right? I'm saving them effort, but, yeah, I don't know. Like, because like in that case, then if they just charge me for 3 designs, yeah, I don't know, whatever. Whatever. So I said this at the beginning of the stream. I found an open source software to drive my Stream Deck. You know, it's the button, the macro panel. I don't have enough wire to hold it up. So basically a macro keypad that has icons on it. And I don't have everything set up yet, so I can't turn the rant disclaimer on. So I'll just have to tell you I'm ranting, I guess. Okay, what else is missing? Have I saved this in a while? That's probably a good idea. So I don't know where this... See, I never found these signals in this other guy's schematic. So I'm not certain. I guess we're going to have to go and figure out what these are, because I don't know where to connect those. But you know what? I'm really itching to run ERC. So let's run ERC and find out. Oh, there we go. I already saw. So horizontal blinking and high res. So why don't we bring horizontal blinking to here and high res to here. All right. What did you just do? That is not what I want. There we go. Okay. Soft 5. Oh, you're killing me. This signal is my least favorite signal in the entire Apple II design. Whatever it is. Maybe that's what I'll go look up tonight is... What the hell is soft 5? Oh. Yeah, the thing is with the Stream Deck, I just like the form factor. Like it's you know, it has a nice stand. The buttons are in a decent layout. It feels nice. All those things. I like the hardware. I really like, and frankly, from a feature perspective, I like the vendor software. Like their software, like it does the things, most of the things you would want it to do, but it's also super dumb. And lately, it won't log into. It won't not even log in. It won't. It keeps losing the OAuth token I give it for YouTube, and that was where I was finally like, you know what, I'm tired of this thing. And then the reason I went looking for an alternative is I want to use the Stream Deck to do some, and I haven't found anything that can do this. I want a software that will send commands to a specific software, because like I want to be able to play and pause say a YouTube video in Firefox while I'm editing a video in Premiere. Because like I go to play something to listen for something, and I want to pause whatever's in the background, but I don't know of a way to send a space bar to a specific application yet. Now the Stream Deck software can't do that either, but ultimately that's what I'm looking for. What I like about this is called Companion is it looks like I could I could maybe write a plugin for it to do what I want. So I can probably get what I want eventually. But the other thing is Stream Deck, just the software is like, the way that it detects changes in your system is kind of intensive. And so anyway, like, I guess it like keeps scanning in Windows anyway. It keeps scanning the registry and to find out whether something's been attached to the USB bus or into USB or something, something like that. And it's like, well, I don't think you need to be doing that. But anyway, so, okay, cool. Now I want to run ERC. So let's do a quick commit. And in fact, why don't I'm going to close this just to make sure all of the schematic files got updated. I'm pretty sure they are without closing, but just in case. Let's just do something like that. Commit to. Oh, that's cool. Yeah, actually, I just switched to LibreOffice. My Office 365 subscription came up, and I was like, why am I paying money for this? The only thing I really used was PowerPoint, and LibreOffice's Impress does, from what I can tell, everything I need. It's definitely going to take a while for me to get as comfortable using it, but feature-wise, I was like, okay, well, this works. And then, like, in terms of Word, I don't really do word processing anymore. And in terms of spreadsheets, I rather use Google Sheets. I mean, even if I didn't like Google, I would create a separate account just to have access to their spreadsheet program. I mean, I guess I don't like Google, but I pay them for my domain services, so I'm going to use everything I can from them. But anyway, I was like, all right, so for an offline office application, I guess I'll go back to LibreOffice, which now I forgot. Is OpenOffice or LibreOffice the one that is a fork of StarOffice? Because back in like the late 90s and early 2000s, when I ran Linux full time, I remember doing my lab reports in StarOffice, and there was a problem with the way it would import bitmap files. And so when I would put the screenshots from our oscilloscope, which saved them as a bitmap, into a document, it got compressed, like seriously compressed for some reason. And I remember turning in one of the lab reports and I got dinged for it. And I told the teacher, I was like, well, I don't know what to do. It's what my program does. And he said, when you get out in the business world, they're not going to care. They're not going to care about whether or not something is open source or free. They're going to care if it looks like shit, and yours looks like shit. It's like, okay. Like, okay, I get you. Eventually I figured out what it was doing, but like, I don't remember now, but it just Professor Jacobs, he did not mess around. Anyway, okay. ERC. Let's see what ERC says. Is Libre a fork of Open? Maybe that's what it is. Was it that Star became Open and then Libre forked from Open or something like that? I don't remember. Not fully annotated. I'm going to skip the annotation. That's going to be fine. I don't want to deal with that right now. Mostly what I'm looking for is what's connected and what's not. So D7. Oh, D7 is not. Oh, I see what's going on. Yeah, so what this should have been is a leaf, because this is only D7. Oh my gosh. I promise I really do know how to use this program, even though it would not appear so by watching me tonight. I hate that. All right, we're just going to deal with it for the moment. Okay, that should get rid of that one. A12 is not connected to anything. You're not connected to anything. Oh, that's not good. Why is these labels not happy? Okay, because that is the wrong bus. Wow. Whoops. Interesting. Yeah, so this was like a month ago when I was trying to decide which one to go with. I did a couple of web searches and I didn't actually find anything that gave a compelling reason to use one or the other. I ended up just doing LibreOffice because I think one of my Raspberry Pi installs had that, and so I was like, all right, well, I'm already using this one. So kind of glad to know I picked the right horse. Okay, so not 7 megahertz clock. I wonder, oh, whoops, let's fix this real quick. This is this will get rid of a couple of errors. I don't know, I mean, at the end of the day, I think just like all options, if whatever you pick, if whatever you use works, then great, it works. For the handful of things that I need an Office application for, it seems like so far it seems to be doing okay. What is this? This should not be a global label. Okay. Is there a phi 1 in this sheet somewhere else? No. Okay. So we need to right click and do change to hierarchy. How do you say this word? Hierarchical. That doesn't sound right to me. So which pen was that in? Oh. Or which box? I wasn't paying attention to which box I was in. Wait, was it this one? Shoot. It was. Huh. Okay. All right. Hey, D3 Jake. Great to see you. Hope you're doing well. Long time no see. Okay. Let's go find phase 0, tilde, highlight that. Read write is still showing up when I do that. Wait, phase 0 or phase 1 should be over here, shouldn't it? All right, well, here's what we're going to do. I'm going to come around down this way. Okay. And then read write is super easy, barely an inconvenience. All right, let's save that. Run this again, down to 16 errors. I'm skipping some of these because I don't care. Yep, I know that's not connected to anything. I know that's not connected to anything. That's not connected to anything. We're going to have to go find out what those are for because that's like 4 of our errors. Let's see. Input pin not driven by... Okay, hold on. Duplicate items. I know the duplicate items. I'm actually going to... Well, we're going to look that up later. Inhibit's not connected to anything. What? Oh, look at that. Hey, check that out. It's actually not connected to anything. Huh. Thanks, ERC. Okay. So let's get down to our 15 errors. I want to try and figure this one out now because this one is more interesting to me. So input pin not driven by any output pins. Okay, so let's figure out what's going on with this one. Star Office became Open Office, and then they went free like 10 years ago. Interesting. I didn't realize it was that old. Yeah, I remember the Oracle Sun sort of stuff going on. Huh. Well, I mean, I work on electronics stuff all day long, so I guess I have a headache all the time. I don't know, debugging and design are the two times that, just like any problem solving exercise, starts to have an impact. Okay, so S and D are both inputs. Okay. Well, duh. I didn't have to open this up to know that. Because D is data, S is set. This is like a what is this, flip-flop? So soft 5, is there a hierarchy label for soft 5 on this page? No. So there should be. The problem is I don't know, so there must be an input to this page. All right, where are we at? We're in CPU. And I'm just going to put this over here for the moment, because where is the nearest soft 5? Okay. I'm going to put it above read write, and we're going to come wire out this way. All right, so that should cover that. So let's see if that takes care of that error. So this arrow might go away. And it did.
And there was much rejoicing.
Yay. So Jake, I forgot what your PCB is doing. I do remember you asking questions about it in Discord, but I don't remember what it is. C6 pin not connected. What? Oh, yeah, okay. Well, we can fix that one. That's an easy one to fix. All right, that should go away. This pin, let's see what's going on over here. So input pin not driven by any outputs. So pin 10 is an input, and it's connected to it's connected to not 7M. Okay. Where are we at? We're in video generation. Here's what I want to know. Does video generation have the not 7M? It doesn't, and that's the problem. That is the problem, I'll bet. So what we're going to do is we're going to take and copy this. I'm going to put it right here. Gonna draw this over to here. I'm gonna copy that. And we're gonna change this to not 7M. That's not gonna do it. Good try, not gonna work. Ah, 2011? Dang. Yeah, Kobe XBMC is something. I mean, I remember running XBMC on an Xbox. So, like, I'm trying to remember for sure when I ran into it, but so I was doing a trade show, and this was like 2016, and I wanted to have a video playing on a loop, and I figured I would just use a Raspberry Pi, connect it behind a TV in the booth, in a flat panel. And I was like, okay, I'll try this Kodi thing. And then I was like, I wonder where this came from. And I was like, wait, this is XBMC? I was like, whoa, mind blown. I totally ended up not using it, but still, my mind was blown. All right, I don't like having these go through the name of the sheet like that, but I don't have a choice. Well, we have a choice. I don't want to deal with it right now. Okay, so now we're down to the solder jumpers. And you know what? Now we're going to figure this out. I want to find out what's up with these. The battery monitor. Okay, I remember the battery monitor thing because I remember we talked about how you could detect the battery levels, right? I think you're going to have like 4 LEDs for the level of the batteries or something like that. You already have them? Aw, shame. So one of the videos I have planned, at least in terms of the title, is around surface mount components. And I want to do something that talks about don't be afraid of surface mount, because if you pick surface mount parts that are 805 or bigger and SOIC and larger, I believe it's actually easier to solder those than through hole. Now, when you get below that line, it becomes a different story. Like that's where your physical agility, to me, if you can solder a resistor into a through hole, you can solder a 1206 or even an 805 surface mount component. If you have the dexterity to do the through hole, easily can do 1206. 805 could potentially be a little more difficult. Below that, different story. But I think people just get it in their mind that surface mount is small, therefore harder. And I mean, if you make your pads big enough, I mean, you can use really big pads that make it really easy to solder on and still use less space than a through hole part. But you get the benefit of, you put everything on one side of the board. It is so much easier to assemble. Okay. I've got to fix the ramp button. Maybe we'll go do that later. I'll go with Red Book. Why not? So we're looking for the video circuit. That looks like RAM. That looks like, well, I was going to say RAM, but it's ROM. The oscillator. Okay. See, I said this, I think, on a previous stream. I think I need to step back and figure out how to make our schematic or our top level schematic look like this. But I think where I'm at is if we get the schematic to pass E or C, then we can blow away what we have and start and redo the top level. Because then it's like just a matter of reconnecting things. But like right now, we've got to fix these other problems because they're like these jumpers that are mislabeled we've got to fix them. So that's where I'm at. I know that doesn't make any sense. I'm thinking, I was going to say thinking faster than I'm talking, but that's, that implies I think at a fast rate. Comparators are awesome. Yeah, well, but I mean, when you get to the other thing is, you know, you could also do something where it's like if you had some through hole parts, you like for example, I'm really a big fan of starting to put. I like putting like the low speed decoupling capacitors on the back of a board. And so if you're doing a design that had some ICs on it, you could either do SOICs, and if you're like, oh, that's too small for me, then put sockets and tape the sockets on the top side, turn the board over, and then solder all your sockets, but then have all the pads for your decoupling capacitors. And then that way you only have to turn the board over one time, and it's super easy. It like that would be like and like 1206 capacitors are still super, well, not, they're easy to find. Like that's, yeah. I'm all wound up. I don't know why. And I can't even blame it on like drinking caffeinated tea or anything, because this is just peppermint. You know, it's the holidays. Oh, excuse me. I should get some caffeine. I don't know what I'm looking for. Let's go back to the schematic. So there is a B14 and an A12. Do we see anything on here that's B14 or A12? There's 13, B12, not A. Okay. So B13 or A12. Wait, did I say B13? Wait, did I get that? Is that what I'm looking for? No. I'm looking for B14 or C. Well, there's a B13, but that's not what I want. I want B14. I want B14 is what I want. Where's B14? Because there's 12 and 13. There's C. I don't see any more gates on here. There's 13 again. Let's go to the next page. Nope, that's not on this page either. Yeah, actually, Christian, the video I'm finishing tonight is a big chunk. So the video I'm working on, it was supposed to be about a state mode logic analyzer. And so for those of you that were around during the Mega 2E project, I kept running into a problem where because the Mega 2 or because the Apple II runs so slow, the digital discovery was a little bit difficult to work with it because I couldn't find a sampling rate that would ignore the propagation or the what I've now learned is the static noise of gates changing on the board between sample periods. And so you'd end up getting I would end up getting these massive captures to see relatively short periods of time. And what I wanted was HP and Agilent logic analyzers had an acquisition mode called state mode, where a clock from the device under test would drive the logic analyzer capture. And so if you were, say, probing a 1 megahertz clock, then you would, or a 1 megahertz system, the 1 megahertz clock from the system would drive the logic analyzer. And then that way you only get samples when the clock is valid, which also helps because you're not looking at a bunch of noise and extra data. So like in a case where I was trying to follow the ROM, I didn't need to see high resolution because I wasn't looking for a timing problem. I was looking for what addresses were we going through. So I started building a state mode logic analyzer, and I had a nightmare getting the RP2040s in the design to work. And so the video became how to debug an RP2040 design, because that's what I spent a month doing. And it all came down to solder problems. Every problem I had was because of solder. And it's because, and I in retrospect, I realized it's because my paste is old. Anyway, a big chunk of the video is how to solder a QFN with just hot air. So like, I wanted to show that it is a difficult package to work with, but if you practice a little bit, it's actually not terrible. You just have to really pay attention, and you have to be able to inspect your work. Like I have a pretty good technique, and I still had pins that weren't connected. So anyway, that was a story nobody asked about. I still haven't found B14. I don't think it exists. Oh, shoot. That's D. C2. I'm just looking anywhere now. I mean, usually these gates are right next to each other because remember the IDs for these chips are the grid on the PCB. So H13 is, and I forget it's column or row, but let's say column H or row H, column 13. Actually, I think it's column H, row 13. You could actually go and look and see where on the board this is. So if there's like a B12, like here, you would expect 12, 13, and then 14 should be right here, because they're going to literally be next to each other. But I don't see it anywhere. Okay, we're gonna look in another book. Which one am I looking at? This is the red book. Which the red book is the 2. I wonder if this is a difference between the 2 and the 2 plus. All right, so we'll go look at this one. I think schematics are, here it is. Okay, I hate this one. I can't read that. I think I have another copy of this because I couldn't read that one. Nope. No. Where? I thought I did. Okay, we'll go look at Gaylor's book, which is my favorite still. A DIY SOC 28 SOJ socket. Wow. Interesting. I found these really good pins from Samtech for making stuff that plugs into what was originally intended for like dips. Super small pins, really soft, but they'll like plug into a socket really well. Wait, there's B14 right there. What? Oh yeah, see that's what it is. I wonder if this is what. Yeah, that's what's going on. So no, it's not. Whatever. Yeah, because here's whatever. Here we go. So Rev 0 doesn't have a B14. Rev 1 does. So this must be that. So like the 2 and the 2 plus are probably different in this regard. Okay, whatever. I just want to fix this, darn it. Now this does make me want to go and try and figure out why are there like 4 versions of the schematic and what are we going to do about that, but at the moment I'm not going to worry about it. Okay, so V5 comes into J13, which is an open, and it connects to J12, which is closed. And then V2 goes to 14, which is an open. And that goes to pin 11 of B14. I can close that. Where is pin 11 of B14? Right here. So this is supposed to be, I think that's supposed, I lost it now, right? So 11 connects to the open, which connects to V2. 11 connects to the open, connects to the V2. So this should be 14. And then 11, which is connected to V1, and that goes to pin 11. This should be 16. And then 12 connects to 10 and 2. Okay. I figure we might as well check these while we're here. And 13 connects to 5. I already checked that one. Okay. So that takes care of those. Let's see if ERC is happy now. I'm going to add a note in here. So all right. Okay, I'm just going to put a note in here just because I'm not going to remember that in the future. Yeah, actually, I've been kind of looking around at a few other microcontrollers, and the PIO is something that's not, it's not as unique as I really thought it was. It's just the most accessible state machine driven GPIO that I've found in a microcontroller. Every other microcontroller that seems to have something like it is significantly more complex, just a more complex microcontroller. So it's more expensive, and it's not as simplistic of a design. Like what I think the reason I like the PIO so much is it's a 32 instruction state machine with 9 instructions, 32 instruction memory with 9 instructions. It can do a little bit of interrupts. It can do DMAs, and it's got a couple of buffers, right? It's everything you need to implement most protocols that run on the order of less than 100 megahertz. And so anyway, I'm amazed at what people are doing with it. So, okay, now we're down to these pins that I have no idea where they're supposed to go. So here's what I'm going to do. So if I look for this phrase, is this anywhere other than video generation? We're still in video generation, That's video generation. So the only place this exists is video generation. So let's go look at the Apple II circuit description and see if we can't find. Okay. So I see a soft 5 here. And I see a B82 here, which came off of B82. Okay, so I wonder, is that what we're looking at? This says A2. That's A2. Okay. Hold on. Okay, so maybe that's not it. I was just thinking that that was close. Or what just happened? I don't want to be on the keyboard matrix. Okay, well, I'm going to work backward now. I don't want the keyboard matrix. I don't see anything like that signal. Okay, here's the next thing. Here's the other thing we should be looking for. I just realized this. So we are looking for A2. All right, what else? I wonder where else A2 is at. So let's look for A2B. So A2B is in the RAM multiplexing. Okay. But that's what we're looking for now is A2. So let's see, this isn't it. That's enunciator. I don't see an A2. I don't see one up here either. Nope. Okay, so I'm going to assume it's not actually on those pages. What about in here? I seen A9. Oh, wait. What is going on? Is Acrobat having a stroke? I'm on page 211 and it keeps wrapping down to 217 for some reason. What am I looking for? A2 or B2? I'm looking for A2, right? I found B2 already. I want A2. There's A3. I feel like we're getting close. Are these? Yeah, so these are multiple revisions of the same stuff. This was video generator. Yeah. I'm not finding it. I don't see it. I just don't see it. I think this guy made stuff up. I guess I could try an OCR search because this is actually a pretty clean scan. So it'll probably work pretty well. Because I just don't see it anywhere. There it is. Found it. So... Well, okay, so I knew about this one. Darn. Got all excited. That's not the one I care about. But how far away can it be from other stuff? That's not an... Okay, here's another. Okay, so same schematic, different version. Same circuit, different version, I mean. See, that's the other half. So that's 1, 2, 3, 4, 5, 6. So okay, so I found half of A2. I mean, just like most of these gates, there's 4 of them in a package. So A1, A2, that's 2 of the 4. Timing diagrams are probably not the direction I want to go. Yeah, no. Okay. This is really frustrating because I don't know what this is for. So why is it in this schematic? All right, I'm just gonna try searching. So where are we on? We're on page 207. I'm gonna do a Control F. If I do an A2, where does that take me? Oh my God. Oh, it's like, oh, I can't find it at all. Wait, what's this talking about? Hold on. Oh my God, this actually works out. So soft 5, revision 7 and earlier boards use high outputs of gates A2A, 8 and A211 instead of R28 to pull up unused logic inputs. Okay, hold on. We're going to just make a quick note of this because that's what this is doing right here. Okay. So where is figure C2 then? Okay, yeah, that's taking way too long. Can I just do, let's see, figure B6? I see B something else. Does this give me a list of thingies? No. All right. Does the table of contents have a list of the figures anywhere? Well, there's C1. Okay, well, the book ends before figure C2, so what the hell? I was hoping they would have, like, some books used to like just list like all the figures and the pages they were on. So that's what I was hoping we would find. Yeah, wait a minute. Where's the schematics at? What if it's figure... So it's not this... That's figure 2224. These are all numbered. There it is. Well, there's C2. So I'm looking for A2 on here. Oh, there it is. Oh, my goodness. Are you kidding me? Are you freaking kidding me? It's just soft 5. What did this note say? Didn't OCR that correctly. Rev 7 and earlier use high outputs of gates A2, pin 8 and 11 instead of R28 to pull up unused logic inputs. So they're supposed to just be connected to soft 5. That's what I'm taking away from this. I don't get what they did. I trust this schematic above anything else. The fact that the signals aren't shown anywhere else in this diagram is another... what were these called before? Oh, you know what? I can just do this. I'm going to look for soft 5 A28. A28 bind. Oh, soft 5. So does this page probably already has soft 5 leaving. What is this page? Where are we at? I cannot believe I finally figured this out. Video generation. Does video generation have a soft 5? It does. And it has it as an input, which I think is wrong. I think it's actually an output. But, or wait. Yep. I think it's an output from this page. So what we're going to do is we're going to delete this. We're going to rename this. And then we're going to rename this. And we're going to delete this. I should have committed before I did all this stuff. Oh well. All right. And then we're going to leave this page. We're going to... Wait. So it is defined somewhere in here. It's not an output from this page. That's why. Okay. So now we're going to, I think there's our cleanup sheet pens. Remove those. Save this. Okay, ERC. Now what are you going to complain about? Output and output are connected. Okay, hold on. Let's do a quick commit because I should have done it before we changed it, but now is probably a good time to among other things. There we go. Okay, let's get back to this, and then let's see if we can solve these 3 ERC issues, because that's actually pretty cool. I wasn't expecting to get this far. I am thinking about diving a little bit deeper into this and try to make the different revisions, but I don't know how far I want to take this this rabbit hole. Okay, so it's complaining that pin what? Well, it's for D13. Pin 15 is connected to A2 pin 11. Oh. Yeah, I see why that's a problem. Yep. Oh man, I feel like this is not good. So let's go find, let's see, where are we at? We're in the clock generation. We need to find, so we're in clock generation. We need to find D13. I don't see a D13 on this page. What about what's down here? That's the video address. Nope. Okay. I think, okay, here it is. Here it is. Okay. So, what is going on here? So D13, pin 15 connects to, so it goes 15 connects to 10 and 7. And then 13's 15 connects to 10 and 7. So 15, 10 and 7, 15, 10 and 7. So those three on all four of these are connected. But then this goes to P2 or a no connect. And that goes to a resistor. That goes to a no connect. And what are this saying down here? So 2 circuit for Rev 1. And then Rev 3 or Rev 0 looks like this must mean that there's like this wraps around and this connects to that same point as here. So I think I know how to resolve this. So if we come up to the top of here, I think this should be, okay, so that's D11, so that's not helpful, but whatever. Well, why? Because this is D14 down here. Oh, God. Okay, it's just upside down. So 14 goes to 10 and 7. I know what's going on. My zoom's messed up because my window's the wrong size. Okay, so 15 goes to 10 and 7, 15 goes to 10 and 7, 15 goes to 10 and 7, but then where does it go from there is the problem. So on 14 to 13, it goes from 15 to 10 and 7, and then that's it. On 14, pin 2 goes to load, I don't know what PS is. I forgot. And then let's see, 3, 4, 5, and 6. So 3, 4, 5, and 6 are grounded. Did somebody just click emotes? Because I saw an animation, but I don't know what it was for. It's okay if you don't want to say. Pin 9 goes to other things. So pin 9 goes to pin 12. Let's just highlight this. Of D13, which also connects to 9. Okay, that's fine. Q0 is H0, H1, H2, H3. Okay. VCC and ground, whatever. Okay, so this one looks correct. So then on 13, so between 13 and 12, so 13 and 12, right? Make sure my head's not in the way. 13 connects to 10 and 7. And then they connect to pin 5, not pin 1. So on 13, 15, its 15 connects up to 12's 10 and 7. And then it goes to, it looks like there's supposed to be a resistor pack out here. I'm going to deal with that in a minute. So 13, so 14 is H4, H5, VA. This is HPE, which doesn't leave. That goes to the clock generator. I'm just going to put a note because I don't want to lose track of what I'm doing at the moment. Pin 11 is VA. Okay, power and ground. So let's see. Pin 1 and 5 should be connected together. They're not. Yes, they are. 5 and the numbers 5 and 6 are different things. My bad. Okay, so pin 1 and pin 5 are connected together, right? And that's soft 5. Pin 2 is connected to load. Okay. Pin 6 is connected to VA, which is basically it's connected around on the other side, which is weird, but whatever. Pin 3 and 4 are grounded. Okay. Hey, Bellum, good to see you. Okay, so now on 12, we've got 14 is VC. This says VB. And 13 is... 12 is V0. Okay. Well, I don't trust. I trust this schematic more. Okay, so let's do the easy ones. So 4 and 5 should be grounded. 4 is grounded. 5 is not. I'm going to move this out here. Let's see, pin 3 on D12. Pin 3 and 6 are connected together, which they are. And then those go to something else. Okay. Okay. So pin 5 connects to 10, 7, and 15 from the one below. So that was supposed to have been connected down here, which I'm going to move to here. Okay. So then number 11, pin 6 should be grounded. Pin 5 and 4 connect to 15. Okay. A jumper somehow. That's this thing down here, which I'm not sure if... Stream's offline. What? That was weird. Did I drop out? Because my dashboard said I went offline, which was interesting because I also heard my network attached to my network drive spin up all of a sudden. Okay. Okay. And then let's see. D11 pin 14 is V2, V3, V4, V5. Pin 15 is not on this schematic. Oh, there it is. Goes through. Okay. So I think I cleaned that up. I'm not sure how I feel about the rest of this stuff yet, but let's at least ERC this and see what we get. Still have... Okay, so then it's complaint. This must be why he... Huh. Actually, let me, I won't spend a lot of time on this. I just want to look at my stats real quick because I'm curious. So as far as OBS is concerned, I never dropped any network frames. So, and we've only missed 50 due to rendering lag, which is actually concerning. This should be 0, but I'm not going to complain. Well, my problem with doing that, my problem with just like doing like making these open or open collector is that that's not how they are in the schematic. So I would rather just ignore the D or C error. I think I get what I see what I get what the circuit is doing, right? The inputs are grounded, and so the output is always going to be a 1. And the Apple II circuit description even says instead of using a pull-up resistor, they're just using these unused outputs as effectively as a pull-up. And so the issue is that's why E or C is complaining, because you would not normally want to do this, because it's very, if this one went high and this one went low, you'd have a short. But because the inputs are grounded, E or C has no idea that these can't change. So yeah, one option is we could actually modify the symbol to change the outputs, like Francois suggested. Hey, GB, good to see you. Squire, saw you pop up as well. So we could do that to get rid of the error. However, I think the better approach is to just say, because will never go low. I think the better approach is we just make a note and we ignore the error, because we know E or C is not wrong, but it's also not right in this case, right? Correct. It doesn't know what the intent is. It just knows that you don't normally do this. But we can look at this and say, you know what, that's okay. We can ignore that. We'll just exclude. In fact, I'm going to change the word to exclude. There. There is a net tie, but net tie won't do. There isn't. Let me back up. KiCad does not have a jumper symbol to do what we want it to do. We should be able to tell it that these aren't connected, but we can't. And I think that's what the original person might have been trying to say. I think they were trying to differentiate these so that it didn't cause a problem. But yeah. So what is ignored? Okay, that's ignored. Symbols that's ignored. That's ignored. Okay, that's okay. I remember ignoring those. What are our errors now, or warnings? I mean. So let's see. CR6, ER6. Okay. I'm going to come back to this one because we need to look that up. What is this one? So D and D. So what is this saying? D3 is graphically connected to bus, but it is not a member of that bus. What? What? Is that what this one is too? D7 is graphically connected, but it is not a member of that. Oh, wait. I see it. Now I'm covering it. D is connected to Jake, actually. There we go. Let's see if that makes those go away. Sweet.
There was much rejoicing. Yay!
Okay. This is in the clock generation. Let's go and see if we can find. So what is the IC we're connected to? We're connected to C1. I'm going to move this because I want this to be more readable. So we're connected to C1. in the clock generation. There's C1 right there. Wow, that was easy. Why wasn't finding all the other chips this easy? And then as soon as I say that, I can't find the page now. Oh, Acrobat. You know, why can't I get rid of you? Oh, I see. So there's supposed to be a jumper block for, is this like at the end of the rows for when you add more RAM? So then are there not jumper blocks in this schematic? Because what did they do for... Huh. Where's E2 at? Well, that can't be E2. Oh, it's the power for E2. Well, wait a minute. How can there be the power block for E2, but there's no chip called E2? What? So where's this memory address? Okay. I think what I'm realizing is there must be something about the way they did the RAM that is, we're missing the jumper blocks in this schematic, which I'm not sure I understand why. So, okay. Yeah, actually, Bill, and that's why I don't like to leave that's why I like to have a line, because I remember when that happened, I was so excited because I knew it would happen, and it finally did. So it's a really high Z bus. Yeah, actually, it's a really low Z bus. Well, it depends on which. I missed when you said that, Jack. I was thinking. Oh, because the one that was disconnected. Yeah. Never mind. The data bus was not connected. So, okay, tell you what we're going to do. We're going to stop here. I really thought we were going to finish it, but I think what I'm going to do is here's what we're going to do. I'm going to stop working on this for now. Next week, I want to play around with KiCad 8. And so I don't know what we're going to do in it yet. Maybe we'll draw, like I've got a couple circuits I need to draw. So maybe we'll do one of those. And I think we're going to come back to this probably after the holiday break. I have a growing desire to basically call this one good for the moment and then go back to the Apple II schematic and just start it over. Because there's just so many fundamental issues with this schematic that I'm worried about it. Like, yeah. I just and what I'm thinking is if we go back and we do the Apple II one first, and then just go back and do the Apple II one first. And maybe what we'll do is I'll just say, let's just do revision 7 because that's the latest. I don't know. Maybe I'll ask the Apple II Slack what the most common board is. The fact that these jumper blocks aren't in this other schematic really bothers me. Because I thought, now I'm thinking, is that a difference? Does the 2 Plus not have? Why is there a 2GS in here? I feel like I know that answer, but yeah, actually, so the KiCad development team, their goal is to do a major release each year. And so I think the last week of January is when KiCad 7 came out, and they're currently targeting January 24th for version 8. The biggest difference with the biggest thing in version 8 is going to be, or the biggest area that got work in version 8 is the schematic editor. And so it's kind of like 7, they focused on the PCB editor. Now 8 will focus on the schematic editor, plus a bunch of other things, but that's where like a lot of changes are coming in. I'm just looking at a couple of things to see if I recognize. I'm looking for... Yeah, okay. Yeah, what I'm so tempted to say is, okay, let's just redo this. Well, the problem with dark mode is they know how to fix it. Like, people have done pull requests to hack ways to make it work, but they're really resistant to do hacks to make dark mode work. The fundamental problem is WX widgets doesn't support it. And so what they really want to have happen is they want WX widgets to support it correctly so that they get the support for free. They don't want to make they don't want to do a hack to make it work. So git commit, do it again, do another one later. Yeah. I don't know. That's just where I'm at. Is I don't want to feel like I totally don't know. I haven't even gone to look to see who created these schematics. I just feel like I've seen so many things now where it's like I have 4 references for the schematic and I can't find some of the stuff that was done. So it's like, what do we do? So I don't know. Anyway, let's go big me. Wait, that's this one. Whatever. All right. Let's see. Did we have an ERC error left? Yeah, so on ERA on RAM signals that should have been in a jumper block. ERC error. Yeah. Well, yeah, I don't know. I tell you what, I don't have to tell most of you this because I think a lot of you have a software background, but watching how some of this stuff, seeing how much stuff is built on top of other things is mind blowing to me. I can't believe that anything ever works. But because it's just amazing to me how it's every single time it's like, well, I would like to have this feature, except we can't because this framework on this dependency and this dependency doesn't support it. And it's like, what? I mean, I even felt a little bit of that on Mega 2 when we were doing tiny USB with the RP2040. The early SDK for the RP2040 had a really old version of tiny USB, and there was stuff, we were getting these like really weird assertions where it's like, I'm trying to remember what it was. It was something related to endpoints. I don't remember what the assertion was, but it was related to an endpoint, and it was really a warning. It wasn't really an error, but for some reason the SDK would crash, or it would assert an error and then bail. But then in Tiny USB, it's like, yeah, like 7 years ago we fixed that. I'm like, well, why aren't you using it then? Jeez. Yeah, you build workarounds to get around the problem with the framework, and then anyway, doesn't matter. You know what? Doesn't matter. Okay, so my current plan is next week we will do we're going to work. I think we're going to take a look at KiCad 8 somehow, and then we'll probably take a week off, and then we'll come back to do we'll come back to this Apple II schematic, because I'm really tempted at this point to say, okay, let's just start over. So yeah. So hey guys, thanks for hanging out. In case you didn't know, the Mega 2 video came out. I don't even know. I forgot what my command for it was. It's either that or that. I don't know. Maybe 8 will get conditionals. Maybe. I don't know. So anyway, Mega 2 stuff is out there. Workbench Wednesdays, all that stuff. If you want to join us, if you're not already on the Discord, I think most of you are. But just in case you're not, there's that link too. If those links don't... Actually, can you guys let me know? I just put 3 links into chat. Did YouTube actually share them? Because I've heard that it doesn't always share links, even if they're mine, which is really frustrating. Okay, thanks. All right, everybody. Thanks for joining. Appreciate you coming by. Hope I can see you next week. If not, if you're celebrating holidays, any of the holidays coming up, have a good holiday. And I'll see you guys around. Take care. Bye. Oh, hey, don't forget, find time to work on something that you enjoy working on. Like, seriously, each week, you should spend some time doing something you enjoy doing. All right? Okay. Bye, Dad. Dad mode off. Okay, guys. See you later.